Whether we sell conveyors, whether we build conveyors, make conveyors, use or work on conveyors, they have problems. And what I want to hopefully discover today is some of the 5 biggest problems that users face when they're not, or things are missed during design, build, upgrades, or those early stages of conveyors. So let's get into it. Number 5 is mistakes with the transition. Okay, if you're not familiar with transition is the distance between the flat tail pulley and the first fully troughed idler. That transitioning of the belt has to be done, or should be done, over enough real estate. If that transitioning of the belt is too short, it will damage the belt. So the transition distance is from this flat tail pulley to this first fully troughed idler. Now, I get a lot of questions about, well, what about this idler, Jared? That's what we call a transition idler, and it's there to support the belt, and it's important, but it doesn't change the overall real estate that's needed, or length of belt that's needed to properly transition that belt to its fully trough. So for this discussion, this idler, although important, it's not relevant in how much transition distance we need. If the transition distance is too short, you're going to see damage right here in the middle thirds of the belt. Let me get into this a little bit deeper here for you to make some more sense out of this. This is what I'm going to call a tension heat map. Overtension in short distances can damage the belt. So what this heat map is showing you is the belt's tension as it transitions from the flat tail pulley to the first fully troughed idler. And you can see the blue is very lower tension compared to the green, which is a much higher tension. What's happening when you stretch, or when you tension, or when you trough that belt, as that belt's developing its trough, the outer edges of that belt are being stretched under greater forces than the center of the belt. And that's what creates this inconsistency in tension. And that's what can eventually damage the belt. So there is some transition distance recommendations, but they are only recommendations. So basically, the transition distance recommendations from SEMA will depend on the trough ability, or the eventual trough of the belt, the tension rating of the belt, or how much stretch is on the belt, and then whether it's fabric or steel cords. So basically what they're giving you in this chart is a factor to multiply times the width of the belt to get what that overall transition distance should be. I worked up an example for you on a 36-inch belt that's troughed to a 35-degree angle. That's at 80% stretch. You would take 36 times 2.4, because 2.4 is the factor that they tell you to multiply the belt width times. That's going to basically give you a need of about more than 7 foot of transition distance. So what they're saying is that the distance from the first fully troughed idler to the tail pulley should be more than 7 foot. And a lot of conveyors don't have that. And then the users, the guys that are on this webinar that said, hey, we're building, or we're working on conveyors, we use conveyors, or we're maintaining conveyors, that's the group that's sitting here joining with us today. They're scratching their head and say, hey, what do I do about that belt damage? The other problem, and this might be even more significant, is when conveyors are designed and they're being loaded on that transition. The belt should be designed, the conveyor should be built in a way that the belt is fully troughed before it's loaded. If you don't fully trough the belt before it's loaded, it makes it very difficult to seal in material and very difficult to seal in air. So that's going to create excess spillage. That's going to create unnecessary dust. That's going to increase cleanup costs. That's going to cost lost material or lost product. And certainly, potentially, it's going to create citations from either OSHA or MSHA on housekeeping. So when you design or build or upgrade a conveyor, and don't take into account that that belt should be fully troughed before you load on it, what you've delivered to the user is a conveyor belt that's just not gonna perform. It's no different than if you were building a car or something like that and sold it, delivered it, built it, designed it, intended it for an end user, and didn't intend it for an end user that was going to drive it to the points that are typical driving. These users must have conveyors that don't spill, don't dust, don't increase their cleanup costs. They're going to have problems with these belts if they're doing that, or if specifically they're loading on the transition.